Good morning, students. Am I audible?
Yes, sir.
Okay. Okay. Good morning. So this is a class of rural water supply and on-site sanitation. So we are in the module 2. I guess this is your last class of the module 2. So do you remember what we have discussed in the last class? You can also write in chat box or you can also speak up. What we have discussed in the last class? Yeah, take any. Disinfectant. Very good. So basically, in the last class we were discussing about uh, chlorination, right? Which is basically it's a part of a disinfection, and the chemical used in the disinfection process is called your disinfectant. Okay, like chlorine is a your kind of a disinfectant, chemical disinfectant. Okay, so we can also go for basically what is disinfection? Killing the pathogenic or disease causing bacteria or microbes, fine, organic matter. Okay, so basically it is the purpose, and the purpose can be achieved by different approach. If you go for physical disinfection, it will be like going for boiling the water. You can, by boiling the water, somehow you can remove uh, pathogenic matters, organic matter, bacteria, microbes, but not all actually. But somehow you can go for it. But boiling is not enough. Okay, rather than boiling, you can also go for utilizing UV rays. Okay, even here also we're going to discuss about something about UV rays. This ultraviolet rays coming from the sun. So under chemical, you can, I have given the list of chemical that can be used as a disinfectant, like potassium permanganate, aluminum copper, right? Then क्या क्या था? Do you remember? Chlorine, of course. Bleaching powder is also kind of a disinfectant, contain chlorine. I think you also, and somehow you have also used bleaching powder in well to purify well water, right? So sometimes bleaching powder is also used to purify water because it contains chlorine. Okay, so what do you know the formula for bleaching powder? Anyone? पता है कि नहीं? Bleaching powder का is it visible? My screen is visible, right? Am I audible? Please to respond. Okay. So yes, bleaching powder. Basically, the chemical composition of bleaching powder is what? It contains calcium, oxygen, and chlorine. So what is the formula? CaOCl2. Okay. So basically, when it mixed with water, basically It break into what? Oh, sorry. Cl2. Cl2. Okay. So basically, when it mixes with water, it produce it produce what? If you break CaOCl2, mainly it contain Ca plus 2, okay, calcium cation, and OCl anion. Okay, so basically, bleaching powder provides calcium and OCl ion, which contain chlorine basically in water. Okay, and that can be used for oxidizing the impurity or oxidizing the other bacteria, microbes, all these things. Okay, so bleaching powder can be categorized under chlorination. You can say you can also have you can also find chlorine tablets also. Okay, so for a very small amount of water, if you want to go for a treatment of very small amount of water, that can be, you can say, the portable water. You can also use chlorine tablets. Okay, so kind of a water which may contain a bucket. So to purify that or to disinfect that particular water, you can use chlorine tablet. Okay, so like this, so chlorine can be mixed with water in different form. Okay, like in the form of bleaching powder. Okay, you can also use chlorine tablet. Okay, then you can also use chloroamines or can be used. Okay, then chlorine dioxide, NaClO2, chlorine dioxide also can be used as a chlorination, but cost of the chlorine dioxide is little high. Okay, chlorine dioxide. So if you want to know the chemical composition, chemical composition is chlorine dioxide. It contains sodium, NaClO2, NaClO2. Okay, chlorine dioxide. But basically, the cost is little high and it is also unstable. Okay, so basically, it is not usually used, but chemically, it can also purify water, or you can say it can be used as a disinfectant. Okay. Okay, though this is about your chlorination. Fine. So rather than that, if you want to, if I tell you about specifically for rural area, so you can also use different disinfectant techniques or disinfection techniques that can be used locally available, or you can say cost effective. Okay. So you can also use a general water filter. Regarding filter, we have already discussed in previous classes. But in that particular filter, you can also add a bio waste like coal, okay, charcoal, you can say, okay. So that can also be used as a disinfectant, okay. Then solar disinfection. That means just uh, keep your water just in the open atmosphere so that the in the presence of solar, that means in the presence of sun energy, from that also you can somehow you can also improve the quality of water, as it's very cost effective. There is absolutely no cost, you can say, if all these component of that purifying substance are locally available. Fine. So let's discuss about that. That means low cost water treatment in rural areas. Fine. So when it comes to low cost, how can you minimize the cost? By using a locally available, or you can say a waste product in treatment plant. Like for example, bamboo charcoal. It is one of the component. Okay, you can you can search in Google, you can find out different innovation regarding water treatment, uh, concentrating low cost. Okay, you can find out. I'm giving you just some example. Like bamboo charcoal can be used. You know, in rural areas, especially in our northeast region, um, the bamboos are available. You can see everywhere. So you can also use the bamboo, burnt bamboo, or you can say that the waste of the bamboo, which is called bamboo charcoal, can also be used as a purifying uh, component for water. Even you also know that bamboo also contain lots of minerals. That means it's the bamboo is rich in minerals. Fine. So even the bamboo charcoal also contain its minerals. So when water goes through the bamboo charcoal, the particular water also carry the minerals from the bamboos. Okay, that's how you can also enhance the minerals composition or minerals quantity in the purified water. Okay, so basically it was uh, coming from the research started from the Bangalore. You can say if you go through research, you will also find out. Okay, so it is not that important, but just given it for your informations. Okay, so basically they have created one innovation or like a new filter containing a bamboo charcoal basically, then gravel, pebble. You know what is pebble? Basically pebble is what your riverbed stone. Okay, that's called pebble, and other locally available natural absorbent to carry out purification. So any in this part in other locally available materials, so you can also search, or you can also in coming semester you can also go for, you can also take up the research project for investigating different or effect of different locally available matter in purifying water. You can also go for it. It's kind of a project like. Okay, fine. Anyway, so you can also use bamboo charcoal, gravel, pebble all together in a different amount and different layer, and that's how you can also go for disinfection process or filtering the water. And why you can use bamboo charcoal? The properties of bamboo charcoal, such as its high porosity, mineral constituents, and absorption rate, and existence of harmless microbes, etc., make it perfect for its utilizing in purifying the water. That means there is so much advantage of using bamboo charcoal because it, first of all, it contains minerals, okay, which is beneficial for our human body. Moreover, it doesn't contain any harmful microbes. Only the minerals it contain. It also have some porosity, high porosity. That means water can pass through its. Okay, absorbent rate also be very good. So overall, it makes this property makes pebble charcoal is good for using in a water filter. Okay. Moreover, the water during the work process purification process, bamboo charcoal even dissolves its rich minerals content into water, so the purified water become mineral rich. Apart from the use of bamboo, they also propose to use gravel and pebble in various stages to aid particle sedimentation and thus further purification. That means they have recommended to use the combination of bamboo, gravel, and pebble. Fine. And during the purification process, also bamboo charcoal provides the minerals into the water. So you can say the the water which coming out of the filter system is also mineral rich, contain minerals which come from the bamboo charcoal. Correct. This is the advantage of uh, basically the advantage of bamboo charcoal. Okay, so it's better to you know remember this, the advantage of bamboo charcoal. Fine. Like I already told you, we have already discussed about UV rays. Okay, By exposing to sunlight, UV rays also play a very important role in filtering and purifying the water by killing the pathogenic bacteria. Okay, it is also eco-friendly and is very indigenous, means it's a locally available and eco-friendly, and also low cost. Fine, and many very less maintenance cost also involved in this particular uh, plant, or not exactly a plant, but it's a process. Fine. So just exposing to the sunlight, it can also purify water by utilizing the UV rays. Fine. Next, it is a solar sterilization is a part of this utilizing sunlight. Okay. So solar sterilization, basically why it's highlighted here, because basically it is solar sterilization is done for saline water. Okay. To purify the saline water, basically the solar sterilization can be used. When solar distillation is used to purify water from saline water like I'm talking about the seawater. Okay, then the particular that process is called solar desalination. Okay, desalination. So in exam may come like question like what is desalination? Solar desalination means actually a solar sterilization basically, and how can this solar sterilization works? So it is a process in which solar heat is used to purify water from an impure water source by evaporation and condensation. That means due to the intense solar energy, the water get evaporate. Okay, and that particular evaporated water can be condensed. That means stored in a particular in top cover, you can say, and a particular from the condensation we can collect the purified water. Fine. And when this solar distillation is used to purify seawater, the process is called your solar desalination. Okay. So how much it can purify? Like if you use completely seawater or contains salt, mainly seawater contains salt, right? So you can say about 3.5% by weight can be remove the salt content. Okay, from seawater the salt content can be removed by 3.5%. Okay, and if when it goes to brackish water means the particular water is coming from the river but it exactly going to the sea. Okay, the brackish water basically a river water but it's going to the sea, but it's also contains saline salt. Okay, so for brackish water also it can remove about 0.6% of salt content. Fine. Solar energy can also be used for desalination either as a thermal energy through the use of solar thermal collector or solar pumps or using electricity. Okay, so these are additional information also given here. Fine. So basically for this up to this point, you have to know these things. The what are the you need to go for finding the locally available or cost effective approach to go for purifying water. So I'm giving some example like bamboo charcoal or utilizing sunlight also or solar sterilization also. You can purify water or disinfectant water. Fine. So this is some example of locally available treatment. You will also find out a numbers of treatment process. You can also find out by yourself. Fine. So anyway, this is all about the treatment plan. Fine. Although right now after this we're going to discuss about a special mineral like iron and manganese. Fine. So iron and manganese is not like that they are too much harmful to human body. Sometimes iron is good for health, but too much of amount of iron or amount of manganese if cross the excessive limit, it will create some difficulty. Okay. So iron and manganese in water also promotes the growth of bacteria basically if it cross the limits. So what are the bacteria produced by the iron? Basically it's known as iron bacteria. Fine. So this microorganism obtains energy from growth from the chemical reaction that occurs when iron and manganese mix with dissolved oxygen. Fine. So this bacteria form thick slim growth on the wall, on the piping system, and on the well screen. That means due to the process of the water treatment plant, somehow the iron and manganese amount of iron and manganese may get increased in water, purified water. But if the amount of iron and manganese cross the limit, then they may um, clog the distribution pipe. Okay. Even you also have seen that reddish color, rusted color created by the iron. Okay. So this presence of iron and manganese is react with oxygen, then it's formed and it creates, or it can crack. It may cause crack on the wall or piping system as well. Okay. This since tends to the rust color from form iron and black color from manganese. That means this rust color coming from the rust color of water or the circumference of the container, it may be caused by the iron, and the black color you will see nearby that distribution pipe. The black color is mainly due to the presence of manganese. Okay, that means somehow we have to remove the amount of iron and manganese from the supply water. Fine. So this bacteria, which is mainly produced by the iron, which is known as iron bacteria, this particular iron bacteria can also be controlled by chlorination. Okay. However, when the water containing iron is chlorinated, the iron is converted from the ferrous state to ferric state. In other words, the rust and manganese is converted into black manganese oxide. This material forms a coating on the inside of the water main, and when they break loose, a customer will sometimes complain of dirty water. So basically, how the rust color, which is coming from this iron, and the black color, which is coming from the manganese, it is explained here. So the presence of iron bacteria is basically removed by chlorination. Okay, but during the process, by removing removing the iron bacteria from the water by chlorination, as a result, that means as a result of chlorination, that particular iron which is present in the state of ferrous state, it is a kind of a chemical um, composition basically. Okay, from ferrous state, the iron converted into ferric state. Okay, and the ferric state of iron mainly responsible for this rust color produced by the ferrous state of iron nearby the pipeline. Fine. And the manganese, because of the manganese, that means which is the coming as a result of chlorination, and it produce a black color coating in the inside wall of the water main, inside of the water main. Okay, so yeah, it will also resist the required velocity or water speed. Fine. So we can also go for removing, or you can also go for reducing the amount of iron and manganese from the water. Clear? So basically, how can you go for removing the iron and manganese? That is concentration of iron or manganese from water, or you can say including fluorides also. So generally, you will also know that even in the area towards your downtown campus also, the water contains fluorides. So somehow we have to reduce or minimize the concentration or amount of fluorides, iron or manganese which may be present in water. So removal of excessive or excess concentration of fluorides, iron, and manganese from water before supply is drinking water is essential as they result in health and economic complication. Okay, health. Okay, we know that excessive iron, excessive fluoride cause an health issue, and also economic complaints means what it will uh, cause failure in the distribution pipe. So in that way, you can say it will also harm the economic point of view. Okay. So removal of these specified impurities, that is fluoride, manganese, and iron, it requires separate treatment steps, and other than those are removal of conventional impurities such as floating and suspended matter or colloidal particles or dissolved organic matter, etc. Basically, that means basically for removal of such impurities, we have a traditional approach of for treatment. Okay, fine. Iron and manganese are removed mainly by inducting oxidation of these impurities. That means even from the aeration process of treatment plant, we can remove iron and manganese somehow. That means iron and manganese can be oxidized by the oxygen, which is done by the aeration process. So iron and manganese are removed mainly by inducting or introducing the water into oxygen or oxidation of these impurities. Oxidation can be carried out either by adequate aeration or using chemical oxidant. Okay, this is also very important term. So you can also go for aeration. That means in the under sky, open sky, you can go for aeration process. I think you have seen the aeration process all over the water treatment plant. So doing the aeration process, water can be go inside the water molecule. Fine, it reacts with the impurity, and the iron and manganese it may present in water get oxidized. Okay, not only iron and manganese can be oxidized, other uh, chemical impurities like H2S, which may create bad odor, can also be removed by precipitation. Okay, so precipitates containing iron and manganese are removed by filtration and adsorption. That means when you go for aeration, that means passing of air into water. During aeration, this iron and manganese get oxidized by the oxygen, and they get precipitate. Precipitate means that get settled in the treatment plant. Okay, so that particular precipitation, the precipitate containing iron and manganese, that can be finally from they are removed by doing filtration, okay, or by adsorption. Fluorides also can be removed by precipitation or coagulation and sedimentation method using chemical. That means fluorides can also be removed in sedimentation plant. Okay, that means after aeration you go for sedimentation process, right? So in the sedimentation process, you can remove the fluoride content. Okay, so even fluoride also get precipitated, that means settle by using some coagulant. You actually you have heard this term, no? Coagulation and flocculation. So do you know any example of coagulant that can be used as a in can be used in a flocculation and coagulation process? So if I give you the example of coagulant that can be used in a flocculation and coagulation process, I'll tell you. So let's in coagulation process, what do? If you remember the whole water treatment plan, you use some chemical, water in a chemical form or a liquid form or the solid form can be used to make some film or paste kind of matter which stuck with the suspended matter. They create they form a kind of a heavy matter, they get settled in the base. Okay, So that particular chemical that can be used in a flocculation and coagulation process or coagulation process, they are known as what? Coagulant. Okay, they are known as they are coagulant. Okay, so coagulant basically the chemical that can be used in coagulation process. So example of coagulant like alum. Okay, so you can also find out the chemical composition of alum. It's little bit lengthy, like Al2SO4 3.18H2O. Okay, you just find out by search in Google. You can find out the chemical composition of alum. Okay, so I'm telling you the chemical composition of alum is what? Al2SO4 3.18H2O. The chemical name of alum is what? Aluminium sulfate. Okay, it's also known as alu aluminium sulfate. Aluminum sulfate. Okay, you just find out the chemical composition. Okay, next can be used copperas. COPPERAS, copperas. Okay, and the chemical formula or composition of the copper is what? FeSO4.7H2O. You find out the exactly one. You will just search in Google. You will find out what is the chemical composition of copperas. FeSO4.7H2O. Fine. You can also use chlorinated copperas. Chlorinated copper. Chlorinated copperas. Okay. That means the particular copperas that we have already discussed. Copperas, before adding in water, copperas is first is mixed with chlorine. Okay. So they form chlorinated copperas. Okay. So this copperas, when it mixes with chlorine, it forms chlorinated copperas. Then it can be used as a coagulant. Fine. Then the last one, your sodium aluminate. Sodium aluminate. Okay. The formula is Na2Al2O4. I may be wrong, just cross check. Okay. Cross check by going through in Google or following the textbook. Al2 Na2 Al2O4, sodium aluminate. So these all are coagulant that all are that chemicals can be used as a coagulant in coagulation and flocculation process. Fine. So using this chemical as a coagulant, the fluoride can be removed. Uh, Fluoride can be removed from coagulation process, coagulation and sedimentation process. That means after coagulation, after using coagulant, it make flock kind of matters. It attract the sediment, attract the impurities, attract the suspended matters, and they get settled. And from the sedimentation tank or sedimentation process, the precipitation, that means the precipitation of fluoride from the sedimentation tank that can be removed. So that's how we can remove the excess of fluorides, iron, and manganese from water. Okay. The common water treatment process such as flocculation that we have already mentioned, sedimentation, filtration or disinfection are employed to remove general impurities such as floating and suspended matters or colloidal particles like dissolved organic matters. Okay, so this can be removed by all these treatment plant like filtration, starting from your sedimentation, then coagulation and flocculation, then again sedimentation, then filtration, then disinfection. Okay, so going through this process, we can remove all the impurities such as floating or suspended matters or colloidal or reactive particles or dissolved organic matter. Okay, or other pathogenic microbes. pathogenic microbes like that means harmful or disease causing microbes. In addition, there are some impurities such as iron, manganese, or fluoride present in water, which does not directly affect the quality of water if present in smaller level or smaller quantity. Okay, but that means I already told you now that the presence of iron and manganese, basically it does not affect the quality of water, but it depends on the amount of how much percentage of fluoride and manganese or iron present in water. We need to, it should be in a permissible limit. Okay, so here in addition there are some impurities such as iron, manganese, and fluoride present in water, which does not directly affect the quality or wholesomeness of the water if present in smaller threshold level, that means in a permissible limit. In fact, iron is an essential element required for human for the formation of hemoglobin, we can say, which is essential in transporting oxygen from lungs to tissue cell. So basically, there are some advantages of iron also. We also our body also need iron. Okay, even for a proper nutrition, human body require 10 to 20 grams of iron intake per day. Okay, and and also even deficiency or deficiency in iron cause anemia in human. So we should maintain our iron limit even our human body. That means overall we cannot say that it is also needed for human body. However, when iron and manganese are present in excess, the water becomes unacceptable for drinking from the aesthetic point of view and for other domestic and industrial uses from an economic point of view, and hence have to remove. That means the basic idea about why we need to minimize the presence of iron and manganese from the water. I already told you it creates some dust color and black color nearby the distribution pipe or where the water is stored. Okay, so it will harm the aesthetic view of the water, and also it will also damage the pipeline. So from aesthetic view and from the economic view also, you can see the excess amount of iron and manganese it will affect. Okay, so we have to go for maintaining or reducing or maintaining the limits of presence of iron and manganese in water. Clear? So this is all about the removal of iron, manganese, and fluorides from water. Clear? So with this, we have completed this module. That means the second module. So in this module, we have discussed about different water treatment plan, starting from point of entry, then point of use, water filter, different type of water filter, different types of impurities. How can we go for removing the impurities? Different locally available, uh, approach that can be adopted for purifying water. For first and foremost, it must give good quality of water, and it's also be cost effective. So both things have to be maintained when it comes to water treatment in rural areas. Okay, so this is all about today class. So is there any doubt till now? So we have another class left. So first I'll take the attendance for you. After that we'll take some times break. Then we again join for. We'll start the third module again. Okay, we'll start the third module today itself. Clear? So if you don't have any doubt, then I'll just close the sharing. I'll closing my sharing. I'm stopping my recording also. If you don't have any doubt, then we'll take attendance. Okay.